You would be stuck, unable to explain half the world around you, without understanding Newton's second law. Seriously, why does a soccer ball fly across the field when you kick it, but a bowling ball barely moves with the same kick? Why do rockets need millions of pounds of fuel? Today, we're going to answer all of that with just 3 letters: F, M, A. Let's dive in. Before we get into any equations, I want you to try something in your head. Imagine you're at a supermarket. You push an empty shopping cart with all your strength. It zooms forward, right? Now imagine doing the exact same push on a cart loaded with 50 pounds of groceries. What happens? It barely moves. Same force from your arms, completely different result. Why? Take a moment and think about it. The answer is mass. And that's exactly what Newton figured out over 300 years ago. So here's the core idea, and I want you to understand this before we even look at the math. The heavier something is, the harder it is to get it moving. That's intuition you already have. And the harder you push something, the faster it speeds up. Also intuitive, right? Newton's genius was combining these two everyday observations into one beautiful equation. F equals m times a. Force equals mass times acceleration. Now that we've got the intuition, let's unpack what each of these letters actually means. All right, let's break down each variable. F is the net force, measured in newtons. How big is a newton? Holding an apple in your hand, that's about 1 newton of force. So when we say 50 newtons, imagine holding 50 apples. Mass, m, is in kilograms. You yourself are probably somewhere between 50 and 70 kilograms. And acceleration, a, is measured in meters per second squared. It tells you how much the speed changes every single second. If acceleration is 3 meters per second squared, that means every second, the object gets 3 meters per second faster. Now here's what makes this equation so powerful. You can rearrange it 3 different ways depending on what you need to find. Need force? Multiply mass by acceleration. Need acceleration? Divide force by mass. Need mass? Divide force by acceleration. 1 equation, 3 superpowers. Now that you've got the tools, let's put them to work. And I promise, the numbers will be easy at first. Let's solve our first problem together. We have a 2-kilogram box, and you push it with 10 newtons of force. What's the acceleration? Step 1. We need acceleration, so we use it equals F divided by m. Step 2. Plug in the numbers. 10 divided by 2. And our answer is 5 meters per second squared. That means every second, this box speeds up by 5 meters per second. Let's verify this makes sense. A small box, a decent push, fast acceleration. Yep, that checks out. Now, what if the box was heavier? Okay, here's where it gets interesting. Same 10 Newton push, but now the box weighs 5 kilograms instead of 2. Before I solve it, what do you think the acceleration will be? More than 5? Less than 5? If you said less, you're absolutely right. Let's check. A equals 10 divided by 5, which gives us 2 meters per second squared. Notice what happened. We didn't change the force at all, but because the mass went up, the acceleration went down. This is the inverse relationship between mass and acceleration, and it's exactly why that loaded shopping cart was so hard to push. Let's zoom out and see the big picture. Look at this chart. Same 100 Newton force applied to 4 different masses. A 1 kilogram object? 100 meters per second squared. That's insanely fast. A 10 kilogram object? 10. A 50 kilogram object, which is about the mass of a person. Just 2 meters per second squared. Do you see the pattern? Every time we multiply the mass, we divide the acceleration by the same amount. This is what physicists call an inverse proportional relationship. And this chart right here, this is Newton's second law in action. But wait, in the real world, forces don't act alone. Let's add friction. You push a 5 kilogram box with 30 newtons, but friction pushes back with 10 newtons. Here's where students make the number 1 mistake. They use 30 as the force. But remember, F in our equation means net force, the total of all forces combined. So net force is 30 minus 10, which is 20 newtons. Now it equals 20 divided by 5, giving us 4 meters per second squared, not 6. This is crucial. Always use the net force. If you remember nothing else from today, remember this. Now that we've talked about net force, let me show you the tool that every physicist uses to keep track of forces. It's called a free body diagram. You draw the object as a simple box. Then you draw arrows for every force acting on it. Push to the right, friction to the left, gravity pulling down, and the ground pushing up. Label each arrow. Once you have all the arrows, finding the net force is just addition and subtraction. Every single physics problem you'll ever solve starts with one of these diagrams. Get comfortable drawing them. Here's something that might blow your mind. Your weight, the number you see on a bathroom scale, is actually Newton's second law in disguise. Weight is just mass times gravitational acceleration. W equals m times g. If you're 60 kilograms and g on Earth is 9.8, your weight is 588 newtons. But here's the cool part. On the moon, where gravity is only 1.6 meters per second squared, your weight drops to just 96 newtons. You'd feel super light. But did your mass change? No. You're still 60 kilograms of matter. Mass is what you are. Weight is what gravity does to you. Before we wrap up, I need to correct the single biggest misconception in all of physics. Most people think you need a force to keep something moving. That is dead wrong. You only need force to change motion, to speed up, slow down, or change direction. Think about a hockey puck on perfectly smooth ice. You give it one push, and it slides forever at constant speed. No force needed to keep it going. The only reason things stop in everyday life is friction. Without friction, everything would keep moving forever. This is actually Newton's first law, and understanding it is the key to truly getting the second law. Let's bring it all back together. Remember those shopping carts from the beginning? Now you know exactly why the loaded cart was harder to push. F equals ma. More mass means less acceleration for the same force. You learn to always use net force, subtracting friction and any other opposing forces. You discovered that your own weight is Newton's second law in action. And most importantly, you learned that force doesn't cause motion, it changes motion. You now have the tools to solve real physics problems. And that's pretty amazing. Great job today.